So both of you, can you just put your roll number in the chat box?
Yes, ma'am.
Yes. Good morning, Subhranshu.
Good morning, ma'am.
Just put your roll number in the chat box, please.
Okay, okay.
I guess we have to wait another 4 to 5 minutes.
Sure, ma'am.
Good morning, Rupali. Rupali, am I audible to you?
Good morning, ma'am.
Good morning. So just put your roll number in the chat box.
Yes, ma'am.
Good morning and welcome, everyone.
Good morning, ma'am.
Good morning.
Good morning.
Anuradha, you are
Anuradha,
from
you are from
Barampur?
Barampur?
Yes, ma'am.
Okay.
Okay.
So because
So because
my,
my,
I guess
I guess
your audio is
your
high,
audio is high.
Ma'am.
somewhat it is
Somewhat it
echoing.
is echoing.
Ma'am.
Yeah, I don't
Yeah,
know
I
why
don't know
this is
why.
happening. Okay, I was also from Barampur. My graduation is from Khaligod College. Anuradha, just put your roll number in the chat box.
Yes, ma'am. Yes, ma'am.
Let us wait for another 2 to 3 minutes and we will start today's class. That is your block 3. That is purely biochemistry part. So, do you have any doubts from the last class? Any of you? Any doubt? Savari, do you have any doubt? Or you are totally clear about last class? I guess she was somewhere. It's me, Bapu. So, can I just know your name, please?
Ma'am, Mangal Naik.
Okay. I guess this is your first class for first zoology class.
नहीं 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 मैम
Okay. So
मैम
previous.
आगुरी आसছি
Okay, okay, okay. So previously you attended. Okay. So
Okay,
just put your roll number in the chat box.
okay, ma'am.
So let us wait for another 3 minutes. Meanwhile, if you have any doubt, you can ask me the question from last class. Welcome, Suchismita and Kavita.
Good morning, ma'am.
Good morning.
Good morning, ma'am.
Good morning. So both of you just put your roll number in the chat box. Just we'll wait for. So, Suchishmita, do you have any doubt from the last class? No doubts. Kavita, do you have any doubt?
No, ma'am.
Okay. So at 8:03 we'll start. Let other people come one by one, but we will start at 8:03. Otherwise, it will not get completed. Okay, we will start now. Let them come one by one. So whether my screen is visible to you?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Yes,
Ma'am.
ma'am. Yes, ma'am.
Okay. So the new people who just arrived, just I request you to put your roll number in the chat box because this is the rule for entering into the class. Okay. So, so today we'll start with this topic that is your biomolecules. Okay. So biomolecules. So how it differs from molecules? So molecules are the basis of a biological systems. So why we call them as biomolecules? Because they constitute this biological system, because something, even if it's cell, it is constituted by lots of molecules that actually constitute your cell. Okay, so the basics of all these biomolecules are certain compounds such as your carbohydrate, proteins, lipids, vitamins, trace elements, as well as your water also. Okay, so those are your biomolecules. Okay, so let us start with this carbohydrate. So anybody from you, can you just tell me the definition of carbohydrate? What can be the definition of carbohydrate? So in our schools we used to read that Swetasara, isn't it? So
Sugars and starches.
yes, yes, can you repeat it?
Carbohydrates are sugars and starches.
Okay, sugars and starches. Okay, those sugars and starches are a type of carbohydrate. But if you see the definition, carbohydrates are chemically polyhydroxyaldehydes and ketones. So you have to refer this definition. Okay, so what is an aldehyde group? In chemistry, you all must have read that. What is an aldehyde group? And what is a keto group? अल्डिहाइड को ग्रुपটা থাকে the functional group is
CO.
CHO. Yes, ketone is CO, C double bond O, whereas aldehyde is CHO. Okay, so these carbohydrates are chemically polyhydroxyaldehydes or ketones. That means when an aldehyde or ketone are gets attached with lots of hydroxy molecule, that gives you carbohydrate. Okay, so a carbohydrate molecule which contains an aldehyde group is called an aldose, and the molecule having the ketone group is called as ketose. Okay, so actually these carbohydrates, which are also known as saccharides, that name derived from the Greek word saccharon. Okay, saccharon means, that means sweet due to sweet taste. Okay, saccharon means sweet, and because it gives a sweet taste, that's why it is known as carbohydrate. So basically, this carbohydrate can be divided into four groups. One is your monosaccharides. Monosaccharides means the simplest type of carbohydrate, and that cannot be broken down into smaller carbohydrate. Those are your monosaccharides. Okay, so as the name suggests, the mono means single, having a only one unit, whereas this disaccharides means when two monosaccharides gets attached with each other are disaccharides. Oligosaccharides means if the monosaccharides are 3 to 20 in number gets attached with each other, those are oligosaccharides. And polysaccharide means if the number is more than 20, those are known as polysaccharides. Okay, now my question to you is that how these monosaccharides gets attached with each other. Monosaccharide mane ପରସ୍ପର ସହିତ କେମିତି attach ହେଇଥାନ୍ତି. How these monosaccharides can get attached with each other. What is the bond? What is the bond between two monosaccharides that can form either disaccharide or oligosaccharide or polysaccharide? Any of you, can you just tell me? You must have studied in your SSC level or plus 2. Any of you? How these monosaccharides are joined with each other? There is a bond known as glycosidic bond. Have you ever heard that? Have you ever heard that? This glycosidic bond? Yes. Someone is trying to speak. Okay, multiple people. Just a minute, let me enter them. Okay. Okay, those who have entered right now, just put your roll number in the chat box. Okay, so we are just going through this carbohydrate. So just started right now. Okay, so the glycosidic bond is the bond by which one monosaccharide can join with another monosaccharide. Okay, so that can form your disaccharide or oligosaccharide or polysaccharide. Okay, so this monosaccharide, which are known as simple sugar, these are actually crystalline colorless compound. So can you just give me example of any monosaccharide? Any of you, if you have known any monosaccharide, କିଏ କହିପାରିବ ଗୋଟେ monosaccharide? So any of you?
Ma'am, glucose.
Yes, glucose, fructose. Okay.
Fructose, yes.
Yes, those are your monosaccharides. So it consists of a single unit. Okay, so these molecules can be either polyhydroxyaldehyde or polyhydroxyketone. If the monosaccharide is polyhydroxyaldehydes, then it is known as aldoses. If the monosaccharide is polyhydroxyketones, this is known as ketones. Okay, so based on the functional group, either aldehyde or ketones, these can be called as aldoses or ketones. Okay, so let us move to the different types of monosaccharides. Okay, so first one is trioses. Trioses means when the number of carbon is 3. So in general, a monosaccharide can be of formula CH2O bracketed N. That means when it depends on the number of carbon, the hydrogen atom will be double and the oxygen number is similar to that of carbon atom. Okay, so the general formula of a monosaccharide is CH2 subscript 2 O bracketed N. Okay, so if we see trioses, it contains a carbon of C3. Okay, so these are the smallest monosaccharides. So minimum carbon required is 3 number, having 3 carbon chain. Okay, so trioses with aldehyde group is called as aldotriose. Example is your glyceraldehyde, and if it contains ketone groups, it is called as ketotriose. That is dihydroxyacetone. So any of you can you just let me know, because this glyceraldehyde and dihydroxyacetone are the part of your glycolysis process, because you are self-studying. So can you just let me know what is the role of glyceraldehyde and dihydroxyacetone? So have you ever heard this term in glycolysis? So in glycolysis, in one of these steps, this glyceraldehyde can be converted to dihydroxyacetone, and dihydroxyacetone can be converted to glyceraldehyde by breaking off 1,6 1,6
One three
yes
one
1,3
one three diphospho. No.
yes 1,3 dies. Sorry, I am just forgetting fructobisphosphate, like that. Not exactly, but it is dividing into one into glyceraldehyde, one into dihydroxyacetone. Okay, so it is not coming to my mind suddenly. Okay, anyhow, so the next type of carbohydrate, sorry, the next type of monosaccharide is your tetroges. Okay, so these are 4 carbon monosaccharides. Those are erythrose and threose. Okay, and sometimes it is also known as erythrulose. So if these are ketoges, these are erythrulose. Okay, if aldoses, then erythrose. Okay, similarly pentoges. So pentoges are your ribose, xylose, arabinose. Yeah, someone is coming. Gayatri, just put your roll number in the chat box. So we just started this class. Okay. So this pentoges can be riboges, arabinose. Okay, again someone has come. So who have just admitted now, please put your roll number in the chat box. Okay. So this pentoges, as I have shown you this ribose. Okay. Where you will find this ribose? Can any of you tell me? Where you can find this ribose? What is the role of ribose sugar? It is a very common question. What is the role of ribose sugar in our body? So this ribose sugar is part of,
मैम RNA रो से जो
yes, yes. This is part of your
R
RNA, and
RNA
ribose sugar is part of your DNA. Okay. So these xylose, arabinose, and ribulose you can find in plant during the photosynthesis, because you must have remembered this ribulose 1,5 diphosphate. Those things are part of the plant product. Okay.
Ma'am,
So
we can also find it in the skeletal muscle.
ribulose, I don't think so. Ribulose? No. Okay, we can.
Ribose, ma'am, ribose.
Okay, okay. Yes, ribose you can find, but not ribulose. So I was talking of ribulose. Okay, thank you. No problem. So the next is your hexoses. Okay, so hexoses are 6 carbon chain monosaccharides, such as aldohexoses. So aldohexoses are your glucose, maltose, mannose, glucose. Okay, and ketohexoses, your fructose and sorbose. Okay, these are all hexoses. So heptose means C7. Okay, these are also you find in some plant photosynthetic pathway. So can you just give me one example of heptoges? So have you studied this uh, photosynthesis part? There is one compound known as pseudoheptulose. Okay, so those are your heptoges. Okay, so these are the structure of certain monosaccharides. So why this? It is here. It is written as D-glyceraldehyde, or this 4 carbon compound as D-erythrose, D-threose, D-ribose, D-arabinose, D-xylose, D-lactose. Why it is written D? So this is a topic of chemistry more than biology. Okay. So why it is written as D?
Ma'am, deoxy.
No, not at all. Anyone? Not deoxy. So it is a type of stereoisomer. Okay. So see how many valency a carbon atom has. Just let me know. What is the valency of carbon atom?
Ma'am, six.
6 or 4?
One.
Huh?
One.
Four, ma'am.
Four, sorry, ma'am. 4.
4. 4. Okay. So the valency of carbon is 4. Okay. So to this carbon atom, so who have come newly, just put your roll number in the chat box. Okay. So this to this 4 valency, 4 types of groups can be attached to the carbon. Okay. So this is known as your asymmetric carbon, which can gives rise to different types of isomers. Okay. So there is a carbon known as chiral carbon. Chiral carbon means asymmetric carbon. Suppose if you see this glyceraldehyde. Okay. So in glyceraldehyde, you will find there is one chiral carbon. That means one asymmetric carbon, because the hydroxyl group can be attached over here and the hydrogen atom can be attached over here. Okay. So that is known as chiral carbon or asymmetric carbon upon which the groups can be arranged variously. Okay. So similarly, if we observe in case of this see glucose, where is that glucose? Yes, here is, there are 4 chiral carbon atom by which the groups can be interchangeable. Okay. And the number of stereoisomers are in the form of 2 to the power n, where n simplifies the n number of chiral carbon atom. So ଯେତେଟା ତମର କେତେଟା stereoisomer ହେଇପାରିବ, so ଯେତେ number ତମର chiral carbon ଥିବ, ମାନେ asymmetric, when the number of of asymmetric carbon, you have 2 to the power n number of stereoisomers. Okay. Understood? Okay. So that is the stereoisomer form. Okay. So what is this D? Okay. So D-glyceraldehyde, if I will say L-glyceraldehyde, that means this D-glyceraldehyde and L-glyceraldehyde are enantiomers. Why it is called as enantiomers? So if we put a mirror over this to this D-glyceraldehyde, then what you will observe? So this is the enantiomers of D-glyceraldehyde. So just imagine the glyceraldehyde is looking itself through a mirror. So the picture that will be generated is your L-glyceraldehyde. Okay. So the D and L forms are the picture form of each other. You can say the mirror image of each other, which cannot be superimposed. Superimposed means they cannot be related with each other. Mane gote upare gote match karibani. Okay. So one is the mirror image of other. So when I am saying this D-erythrose, D-threose and D-ribose means there is another form that is known as L-erythrose, L-threose, all are mirror image of each other. So in nature, you will find more D type of carbohydrate than L type of carbohydrate. That means in nature, you will find more profoundly found, you will find this D-erythrose, D-threose or D-glucose rather than the L form. So in our body also, you will find more number of D monosaccharides. Okay. But this is just reverse of amino acid. Okay. So in amino acid, which form is much more abundant, D form or L form? So in amino acid, the L form you will find naturally in the eukaryotic cell. Okay. So in case of amino acids, the D form is only present in the cell walls of bacteria, some algae, you will find this D form of amino acid. Whereas in case of carbohydrate, you will find more of these D monosaccharides are found in our body, and that can form the glycosidic bond. Okay. So this is L. This is why it is called as aldose, because one aldehyde group is there. Okay. So this is L-glyceraldehyde. This is D-glyceraldehyde. So these are known as your enantiomers. Okay. So okay, before going to Fischer projection, I have another thing to say. So besides this DL isomerism, another type of isomerism is also found, which we denote as small d and small l, or the D form can be written as plus and the L form can be written as minus. ହେଲା ଏଠି ଯେମିତି ତମର capital D ଲେଖିକି ଗ୍ଲିସରାଲଡିହାଇଡ୍ ଲେଖୁଛୁ, ସେଇଠି ସେମିତି ଆମେ ସ୍ମଲ୍ ଡି ଲେଖିକି ଗ୍ଲିସରାଲଡିହାଇଡ୍ ଲେଖୁଛୁ and small l ଲେଖିକି ଗ୍ଲିସରାଲଡିହାଇଡ୍ ଲେଖୁଛୁ. There, what do you mean by that D or L, or you can say D implies to plus and L implies to minus? What does it mean? Anyone? Have you heard about the term dextrorotatory and levorotatory?
No, ma'am.
In chemistry, you have not heard that term, dextrorotatory and levorotatory. Okay. So that DL form, or you can say plus and minus form, implies to the molecule when a plane polarized light passed through that molecule, and if it moves that plane polarized light to the right side, that is known as dextrorotatory or plus form, or if the plane polarized is moved to left side, that is known as levorotatory or minus form. So that small, जदि एठी मु लेखि थांती D glyceraldehyde, D टा small माने small letter लेखाई थांता, then what does it implies? That means that glyceraldehyde is dextrorotatory in nature. That means it is moving the plane polarized light to the right direction. Otherwise, this can be also designated as plus glyceraldehyde. So don't confuse that one with this one. So these are isomers and these are enantiomers, and those are known as optical isomers. Okay, so your monosaccharide, it can show both stereoisomerism as well as optical isomerism. Okay, so have you understood? Anybody has any doubt from this?
No, ma'am.
Okay, so the next one is, so how to represent a D-glyceraldehyde or L-glyceraldehyde. Okay, so Fischer, one of the scientists who actually projected one formula to how to write down this D-glyceraldehyde and L-glyceraldehyde. Okay, so this is from your book, but somehow it has written in wrong way. This is your perspective formula and this is the Fischer projection formula. Okay, so see this D-glyceraldehyde. So these are your vertical bars and these are your horizontal bars. So in Fischer projection formula, so how to represent this formula actually tells us how to represent these molecules in a 3D structure. Okay, so a molecule is there, so how to represent it in 3D structure out of the paper. Okay, so this D-glyceraldehyde can be written like this. So what it suggests, so those vertical bars can be written away from the paper, and these horizontal bars will represent out of the paper. So if you observe, so towards the reader. Okay, so eta hochi tomar horizontal bar. So this horizontal bar mane eta horizontal bond, hydroxyl group and hydrogen group. So eta kimiti how to represent it this? So it will be represented like it will be faced towards the reader, mane amadaku से मुहेची से टाइप रो रिप्रेजेंट करिया को हबो आउ वर्टिकल बाटा को किमित रिप्रेजेंट करिया को हबो away from the paper in the other direction. It is represented like that. So this is the Fischer projection formula. Similarly, if you observe this L-glyceraldehyde, what you will observe? This aldehyde group and this ethyl group, both are away from the paper, and this hydroxyl and hydrogen group are towards the reader. So this is the Fischer projection formula to how to write a monosaccharide in Fischer's projection formula. Okay. So there is one important point also. So in stereochemistry, DL form does not represent the optical rotation of plane polarized light. Okay, so what is this DL form? These are only mirror image. So these are stereoisomers. It is not going to represent whether it is a plus form or minus form. So if we see one example, both D fructose and D glucose have the same stereochemistry, that is hydroxyl group at C5 on the right side. So this is a ketose and this is aldose. So both have the same stereochemistry. So both are the D form and hydroxyl group is on the right side of the carbon atom. Okay. So but behave differently in terms of optical activity. How? The D fructose is levorotatory while D glucose is dextrorotatory. So how we can write this D fructose? We can write minus or small l D fructose, while we can write down this D glucose as plus or small d capital D glucose. Okay, understood. So the plane polarized light rotation is something different from the mirror image. Okay, so those are your optical isomer. So we can't say that if we are writing something D fructose or D glucose, both have same optical activity. So the optical activity may be different. So it can be either levorotatory or it can be dextrorotatory. Okay. So now come to the cyclization of this hexoses. Okay, so I am giving you example of hexoses. Okay, so there is one pentacyclic ring that is known as pyran ring, and there is a hexacyclic ring that is the pyran ring, a pentacyclic ring known as furan ring. Okay, so D glucose does not stay in a straight line. আমি যেমন দেখছো এটা straight line রে আছে, originally it cannot be like a straight line. Okay, why it cannot be like straight line? Because this aldehyde group present on the first carbon can react, can form a partial hemiacetal bond with the C5 position. Okay, so this cannot remain as a straight structure, or you can say in the extended structure, rather it forms one hemiacetal ring. So this ring is known as hemiacetal ring in case of glucose, and in case of fructose, similar type of ring between C2 carbon and C4 carbon is known as hemiketal ring. Okay, so can you just mark the difference? So here, what is the carbon number that forms this hemiacetal ring? That is the first carbon. But in case of ketones, you will find this ketone group. That is the second carbon that forms the hemiketal group. Okay. So when it forms the ring, it gets cyclized and the structure similar to a compound known as pyran. So that's why this type of ring is structure is known as pyran ring, and here this ring structure is similar to a compound known as furan. Okay, so this is known as furanose and this is known as pyranose. Okay, so wherever you will find the monosaccharide forms a pyran ring, it is known as pyranose. Whenever you find it forms a furan ring, it is known as furanose. Okay, so if the compound, the extended compound forms hemiacetal ring or hemiketal ring, the number of chiral carbon increases or decreases. My question to you is that if this particular extended structure gets cyclized, whether the number of chiral carbon increases or the number of chiral carbon decreases. Any of you? Chiral carbon number ta badhibo na komibo? Chiral carbon means asymmetric carbon. Whether the number of asymmetric carbon will be more or the number of asymmetric carbon will be less.
Or
Yes, I couldn't hear. Yes, let me know. कौन कोचले टिके कहले बेटर होबो?
more हवा.
More. Okay, so it will be more. Okay, so see, when this carbon at first number reacts with fifth carbon, it partially it is the hydroxylated. Okay, so because this hydrogen gets transferred over here. Okay, so this is the hydroxyl group where it gets react, and this hydrogen is gets transported over here. Okay, and but when this hydroxyl group is created, that can remain in the upper side or can be in the lower side. Okay, so this is now known as alpha or beta. So this is another formula known as Haworth projection formula. What tells us that in the asymmetric carbon, the position of hydrogen and hydroxyl group determines another type of stereoisomer, that is alpha or beta. Because this glucose stays in a pyranose form, it is known as glucopyranose, and it is a D structure. যদি ঠিক তার মিরর ইমেজটা হইথান্তা দ্যাট উইল বি এল স্ট্রাকচার। সো সেইটি আমি কোন লিখতান্তা এল গ্লুকোপাইরানোজ। এটা যেহেতু ডি স্ট্রাকচার আমি লিখলে ডি গ্লুকোপাইরানোজ। Okay, why it is known as alpha? Here the hydroxyl group is at the towards the downward. Okay, why it is known as beta? The hydroxyl group occupies the upper position, so it is known as beta. So this is another type of formula known as Haworth projection formula. Okay, now let us come to this ketones. Okay, so as I told you, this second carbon in the ketone group reacts with the fourth to the fifth carbon. Okay, and here also you will find the hydroxyl group reacts with the ketone group. Okay, when hydroxyl group reacts with the ketone group, so at one position the hydroxyl group is at the lower end, and another position this ethyl group is in the upper end. Here, if the ethyl group is in the upper end, it is known as alpha form. So it will be alpha D fructofuranose. Okay, so sorry, I just mistakenly told you. Yes, in both the cases, you can observe the hydroxyl group are in the lower, occupying the lower position. So both are alpha D, either glucopyranose or fructofuranose, because it contains the furan ring. That's why it is known as fructofuranose. And here also it is beta D fructofuranose, because the hydroxyl group is occupies the upper position like that of beta D glucopyranose. Okay, so naming convention you have known, that is the Haworth projection formula. Okay, so now from this we will derive certain disaccharides and you can say other polysaccharides and oligosaccharides. So one of the derivatives of monosaccharides are so let us go to some derivatives of monosaccharides. So one is your amino sugars. Okay, so in amino sugars, as the name suggests, when the one of the hydroxyl group of sugar gets replaced by an amino group. Okay, so suppose for example is alpha D glucosamine. Here what you will find in the second carbon, the hydroxyl group is replaced by the NH2 group. Similarly, N-acetyl glucosamine. So these are part of the chitins, this glucosamine and N-acetyl glucosamine and alpha D glucosamine. These are part of the chitins. Okay, and these are found in exoskeleton of crustaceans and insects. Okay, similarly, if we see the structure of D-ribose and deoxyribose, what you have told, this is part of your RNA. Okay, so this is the 5-carbon sugar. Okay, so in D-ribose you will find there is a hydroxyl group in the second position, whereas in deoxyribose, which is part of the DNA, this oxygen is not there, as that's why it is known as deoxyribose sugar, which is part of your DNA. Okay, so let us go to now the structure of maltose, which is a disaccharide. So in maltose, what happens? There is a reaction between alpha D glucose and beta D glucose. That means the hydroxyl group in alpha D glucose here, and the in beta D glucose the hydroxyl group is here. The hydroxyl group is here, but it reacts to the other carbon. Okay, so in this reaction, here hydrolysis occurs followed by a condensation reaction, which gives rise to one acetyl ring over here. So how it can be chemically written? It can be written as alpha D glucopyranosyl, because it is a pyranose ring. Okay, and the bond is formed between 1 and 4th carbon atom. So the direction will be mentioned as 1. Ethi tiro chinhota dekhauni, there will be a one arrow mark. Okay, 4D glucopyranose. Okay, like that the naming convention can be done. Okay, so both the glucose can form one maltose by this 1,4 alpha 1,4 linkage. Okay. So similarly, in case of lactose, so you just let me know what it can be chemically said. So I am not going to tell you. See this picture and let me know what it can be told. How we can name it. So this is galactose and this is glucose. So see, once again, see this one. So both are D form. In nature, you will find D form of monosaccharides. Okay. Any of you? Any of you? Can you just let me know?
Galactose 1 for glucose.
Yes, alpha. This is yes, alpha.
Alpha galactose 1 for glucose.
Galactopyranosyl 1,4 beta glucopyranose. Okay, so like this. Alpha D galactopyranosyl 1,4 D glucopyranose. Okay, instead of gluco, rather it will I can say here galactose. Okay, galactopyranosyl alpha D galactopyranosyl 1,4 D glucopyranose is your lactose, where there is a hydrolysis and condensation reaction between galactose and glucose. Okay, so this is the structure of lactose. Okay, similarly, what it can be said, let me know. So this is a reaction between glucose and fructose, which is known as sucrose. So eta ko kon koi periba ame chemically? What we can
alpha D glucose 1 to fructose.
Glucopyranosyl. Alpha D glucopyranosyl. Yes. 1,4
beta D fructo
furanose.
furanose.
Yes, very good, very good. Thank you very much. Okay, okay. So that's how we can name these disaccharides. Okay, so someone has come. So please, who have admitted recently, I again request you to put your roll number in the chat box. Okay. So those have admitted recently. So I just request you to put your roll number in the chat box. Okay, because I guess 15 persons are there. Okay, so I need 15 roll numbers over here. Okay. Okay. So thank you. Somebody raised your hand, raised the hand. Anyone who want to ask the question? No? Okay. So, okay. So, yeah. One thing I just forgot to tell you, like that, if for extended structure, the asymmetric carbon is known as chiral carbon. In Howard's projection, the asymmetric carbon is known as anomeric carbon. Okay, anomeric carbon. Okay, there in extended structure, it is known as chiral carbon. It is known here, it is known as anomeric carbon. Okay, so sorry. So I am just showing the different. So these disaccharides you have known. So now come to this oligosaccharides and polysaccharides. So as I told you earlier, these oligosaccharides are made up of 3 to 10 number of monosaccharides unit. So one of the example is your raffinose. Okay, so raffinose is a trisaccharide where you will find this it in a plant product. Okay, so in beans, peas, cabbage, okay, broccoli, you will find this raffinose. Okay, so now come to polysaccharide. Okay, so polysaccharide in nature you will find most of the polysaccharides in the form of glucose, okay, either in the plant or in the case of animal. Although there are certain derived polysaccharide, but mostly you will find there are homopolysaccharides, okay. So homopolysaccharide means when the polysaccharide contain a single monomer, uh, or you can say only a single type of monosaccharides. Manakaro glucose ro chain ach. So that is known as a homopolysaccharide. So heteropolysaccharides are those where the monosaccharides or the variety of monosaccharides are different. Okay, those are known as heteropolysaccharide. So come first to the homopolysaccharide. So first one is starch. So as you all know, it is found in case of plants. Okay, so this starch is made up of all alpha D glucose, and it is composed of two types of polymers. One is your amylose, another is your amylopectin. Okay, so it contains about 10 to 30% of amylose and 70 to 90% of amylopectin. So this amylose has alpha D glucose unit linked by 1,4 glycosidic bond. Okay, so but this amylopectin, sorry, so in amylose all the units contain alpha D glucose. Okay, but in amylopectin it has a coiled structure, and this is although it is joined by alpha D glucose unit by 1,4 glycosidic bond, but at every 24 or there are certain branches at certain points in case of amylopectin, and those branches are connected by alpha 1,6 glycosidic bond. মানে বুঝি পারছো, amylose is similar to amylopectin, all have alpha D glucose, all are connected with 1,4 glycosidic bond, but in amylopectin there are certain branch points. Branch points মানে মনে করো straight আছে. If the polysaccharide is straight, at some point there is a branch point where you will find alpha 1,6 glycosidic bond. Okay, that is amylopectin. So similarly, glycogen. So glycogen, also known as animal starch, where it is stored? It is stored in the liver and muscles. It has the similar structure to that of amylopectin. That means it has 1,4 linkage. Okay, alpha D glucose are linked with each other by 1,4 linkage, but at certain points, the branch points, there is 1,6 linkage of the monosaccharides, or you can say the carbohydrate chains, and the amount of glucose units are more in case of glycogen than that of amylopectin. Okay, glycogen ro glucose unit gudaka sankhya ra adhika. Okay, so now come to cellulose. Okay, so here the glucopyranose residue linked by beta 1,4 glycosidic bond, not by alpha 1,6 glycosidic bond, rather it is linked by beta 1,4 glycosidic bond. So you know where you will find this cellulose. So in different plant cell wall. Okay, so in herbivores they contain cellulose enzyme to digest that. Okay, so next one is your heteropolysaccharides. So someone has come. So I request newcomer to put their roll numbers in the chat box. Okay. So next one is your heteropolysaccharides. So one of those is glycosamine glycans, or known as GAG. So any of you, have you know where we found these GAGs, glycosamine glycan? Just give me a quick reply if you know that. So you will find these GAGs in the matrix of cartilage and bone. Okay, so GAG, so it in combination with collagen, it forms the matrix of this cartilage. Okay, so those are known as your, sorry. So those are known as your glycosamine glycan. Okay, sorry. Okay. So those are your glycosamine glycan. Okay, so how it is created? So it consists of a uronic acid. Okay, and the type of linkage is O-glycosidic linkage. Okay, now why I called it a O-glycosidic linkage? So there are actually two types of glycosidic linkage. One is O-glycosidic linkage and one is N-glycosidic linkage. So Can you just tell me what is the difference between a O glycosidic linkage and N glycosidic linkage? So glycosidic linkage आमे देखले 1,4 linkage, 1,6 linkage, beta alpha देखले. Now what is O glycosidic linkage and N glycosidic linkage? See, if the तमे जो ग्लूकोज ग्लूकोज भितरे देखला बॉन्डिंग ता that one be, is O glycosidic linkage or N glycosidic linkage. दीटा ग्लूकोज भितरे जो बॉन्डिंग हैला सेटा O glycosidic linkage ना N glycosidic linkage. That one is O glycosidic linkage. So if the glycosidic bond involves a hydroxylic group or oxygen group, that is known as O glycosidic linkage. Suppose if I have shown you one amino sugar, okay, in amino sugar what you will find, one NH group is there. So if the glycosidic linkage involve a nitrogen atom, that is known as N glycosidic linkage. Okay, जदि ऑक्सीजन थिबो ताहले O glycosidic linkage, जदि nitrogen थिबो ताहले सेटा हला N glycosidic linkage. So many of the amino sugars you will find that they have N glycosidic linkage. Even the linkage between your deoxyribose and the base, that is your adenine, thymine, guanine and cytosine, they have the N glycosidic linkage. Okay. So similarly, some other types of these heteropolysaccharides are your chondroitin sulfate. Okay, that is also present in your cartilage and cartilage pads. Okay, keratin sulfate. Okay, so you will find this in cornea, cartilage and bone. Okay, hyaluronic acid that you will find in different tissues. Okay, heparin. So heparin, you know, it is an anticoagulant. It is also a type of heteropolysaccharides. So these are all heteropolysaccharides. So homopolysaccharide, you know, those are your starch, glycogen, cellulose, etc., etc. Okay. So now let us go to the amino acids. Okay. So amino acids so these are the smallest units of what? Proteins, isn't it? So let us go to a single amino acid. What structure does it have? Okay, so in a single amino acid, what you will find, there is one asymmetric carbon atom which is known as alpha carbon. Okay, and so this is what sort of formula I have shown you. Eta kono? What type of projections is this one? In extended carbohydrate structure, I have shown you something out of the paper, away from the paper. So what sort of projection this one is? So is it visible or not? So can you see this screen?
Yes, ma'am.
What sort of projection it is?
Fixture.
Right now, Fischer projection. Okay, so this is the Fischer projection. Okay, so this is the asymmetric carbon atom. So to this asymmetric carbon atom, what you will find, there is one carboxylic group, one amino group, one hydrogen group, and these three will remain constant for every amino acid. Then what will get changed? Only this R group. Okay, so this is the basic structure of the amino acid. Okay, so according to different R group, the amino acids can be categorized into different form. Okay, so the simplest type of amino acid, so you must have studied, self-studied. What is that simplest type of amino acid? Where you will not find this R group, rather you will find a hydrogen over here. What is that amino acid? R group नथिबो हला. R group माने कोन जे कोनसी गोटे organic group. Okay,
Glycine.
glycine. Okay, so the smallest type of, simplest type of amino acid is your glycine. So where you will find one hydrogen instead of R group. Okay, so when we are classifying these amino acids, these are neutral non-polar amino acids. Okay, so the neutral non-polar amino acids are your glycine, alanine, valine, isoleucine, leucine, methionine, proline, phenylalanine, and tryptophan. So these are neutral non-polar amino acids. Neutral means the charge is 50% they are not, you can say they are in a perfect deuterionic form. So the amount of positive charge is equal to the amount of negative charge. So these are neutral. And non-polar means these are not soluble in water, rather these are soluble in solvents like ether and other non-polar compound. Okay, so if I'll please write your roll number in the chat box. Okay, so this if you see the structure, all of them are amino acid except one. Can you identify that one? All of these are amino acid except one. So what is the basic structure of amino acid? There is one carboxylic group, one amino group, there must be one hydrogen attached to that, and there must be certain other organic group. See, all these have such type of thing except one here. Which one is not actually an perfect amino acid? କହିପାରିବ କୋଉଟା ଗୋଟେ amino acid ଭଳିଆ ଦେଖା ହଉନି ତମକୁ ୟା ଭିତରୁ? ଦେଖ ଏଠି ବି ଅଛି, କଣ ଅଛି? कार्बन अच्छी, अमीनो ग्रुप अच्छी, कार्बोक्सिलिक ग्रुप अच्छी, गोटे आर ग्रुप अच्छी, गोटे हाइड्रोजन अच्छी ट्रिप्टोफान। सो कोटा तुमको अमीनो एसिड भलिया देखा होनी? व्हिच वन डज नॉट सीम लाइक एन अमीनो एसिड?
Ma'am, third one.
Third one, what is that? This one?
Yes, ma'am.
Yes. So this is the proline. So it is amino acid instead of amino acid. So this, although we are taking this into the amino acid, under it comes under the 20 synthesized amino acids in our body, but we consider it as amino acid because you will not find here a perfect NH3 group over here, and here the organic group or the R group is cyclized along with the amino group. Okay, so this is amino acid rather than amino acid, this proline. Okay, so next one is your neutral polar amino acid. Neutral means the charge is, of course, the plus charge is neutralized by the number of minus charge. So here you will find serine, threonine, tyrosine, aspargine, glutamine, and cysteine. So these are all neutral polar amino acids. Okay, so the next one is your acidic amino acid and basic amino acid. So acidic amino acid can be called as acidic amino acids are aspartic acid and glutamic acid, where you will find an extra carboxylic group in the R region. Okay, jodio taro gote basic carboxylic group achi, but the R group also contains an extra carboxylic group. Similarly, in case of basic amino acid, you will find there are certain extra amino groups. So these are all your basic amino acid: lysine, arginine, histidine. Okay, so besides this sort of classification, okay, we'll also find another types of classification based on the group. Suppose if I'll say cysteine, this cysteine contain sulfur, as well as here you can see this methionine also contains sulfur. So we can tell this that these are all sulfur containing amino acids. Okay, similarly, we can classify as hydroxy containing amino acids. So which are hydroxy containing amino acids? So there is an extra hydroxyl group over this serine and threonine. So these are known as hydroxyl containing amino acids. The you can these are amide amino acids because, so in aspartic acid, so if you see this aspartic acid and glutamic acid, if one amino group is added over to that, that becomes the amide group. So these are type of amino acids which contains amide group, that are your aspargine and glutamine. Likewise, we can also classify this particular type of amino acids. Okay, now there is another feature of this amino acid. As I told you, this positively charged and negatively charged amino acids are based on the property or based on the pH in which the amino acids are there, because the amino acids used to change their charges according to the pH level of that particular solution. Okay, so the positivity and negativity of amino acid, that actually depends on the pH in which it resides. Okay, the pH level, suppose if I'll say this one, this aspartic acid and glutamic acid, at neutral pH, these are negatively charged. Kon pai na tankara dita carboxylic group ଅଛି. Okay, so at neutral pH it becomes negatively charged, but when the pH gets higher level, it subsequently it comes to a neutral pH level, sorry, neutral charges. Okay, so accordingly you cannot classify amino acid according to charges, because the charges will vary according to different pH level. Okay, so the property of amino acid is that it forms peptide bond. So if you see the formation of peptide bond, what happens? One amino acid, the carboxylic group of one amino acid reacts with the amino group of another amino acid to forms this CONH bond. Okay. Now, the peculiarity about this peptide bond is that the CONH bond is not present in one plane, or it not allows the bonds which are attached to it to rotate freely. Okay, so there are certain peculiarity about this peptide bond which leads to hypothesize Dr. D. Ramachandran a theory known as Ramachandran theory. Okay, so in 1930, this Linus Pauling and Robert Corey, they studied a lot of things about the understanding the protein structures. Okay, so they started analyzing this peptide bond. Okay, so there are three covalent bonds arranged in a series. One is C. This particular carbon is known as C alpha, and this is also C alpha. So the three types of covalent bond is one between C alpha and carbonyl C group. Another covalent bond is between carbonyl C group and the N group, and another covalent bond between this N and this alpha carbon. Okay, so three types of covalent bonds are there. Okay, so what they found is that this particular CN bond is so they observed this is a single bond. It is not a double bond. But what they observed that this CN single bond is somewhat shorter than the CN bond in a simple amine, and that the atoms associated with the peptide bond are coplanar in nature. Okay, so what they found the bond angle in this CN bond is somewhat shorter than a CN single bond. जदि गोटे normal CN single bond रो जहाँ bond length रोची ताठरो यार bond length टा कम रोची हला, and the bond length is in between CN single bond and CN double bond. Okay, so this indicated a resonance or partial shelling of two pairs of electrons between carbonyl oxygen and the amide of nitrogen. So what he observed that because it has a partial double bond character, that's why the groups which are attached to it are not freely rotatable. Okay, and all the these bonds are coplanar in nature. Coplanar mane dekho, they resides inside a single plane. Okay, and the angle between these two planes is known as dihedral angle. So in case of a peptide chain, you will find different dihedral angle, but these atoms, that is the oxygen, this carbonyl carbon, this C alpha and this C alpha, they lies on a single plane. Okay, so what he then named that the bond between this C alpha and nitrogen is known as phi bond. Okay, and the C alpha and carbonyl C, this bond is known as phi bond. So whatever the structure of a peptide or the 3D structure of a peptide, that depends on the rotation of this phi and psi bond. Mane gote 3D structure gote peptide bond ro kiye determine korchi? The phi bond, that is the nitrogen and C alpha bond, and the psi bond, that is the carbonyl carbon and the C alpha bond. Okay, so he deducted from that. Okay, so that leads to Ramachandran plot. But anyhow, in your book, this Ramachandran plot is not there, so I am not going into deep. Okay, so let us go to the properties of this amino acid. So here you can see these are the structural formula. Also, this particular picture is from Harper's Biochemistry. Okay, so there are different pK values. Okay, now you can here ask me a question: what are these pK values? Okay, so there is a value known as K alpha, Ka, okay, which is known as acid dissociation constant. Okay, so any of you, can you just tell me what is a acid dissociation constant? In chemistry, you must have studied this acid dissociation constant. So this is the constant. Okay, this is the number of removable hydrogen ions from a particular molecule or particular compound is your acid dissociation constant. Okay, so this pK1 is the pH of one acid dissociation constant, and pK2 is the pH of another dissociation acid dissociation constant, and pK3 is the dissociation constant of the R group. Okay, so every amino acid will dissociate hydrogen atom, or can give out hydrogen atom, or you can say it can behave as acid at particular pH. Okay, suppose if I'll say glycine, it has one carboxylic group and one amino group, so it can give out one hydrogen ion at pH 2.4. So another hydrogen atom from the amino group, it can give out at pH 9.8. Okay, so there is another terminology known as isoelectric point. Okay, so isoelectric point is the point where, or the pH at which the charges become neutralized. That is the isoelectric point. So this suppose I would say tomar jeto khiro ru chhenna chiduchi. Okay, so when this you can say this cheese and paneer is made, what actually happens? So casein is a type of protein. So it gets precipitated at its isoelectric point. That means where its positive charge amount and negative charge amount are equal. So they tend to coagulate and they tend to precipitate. So that is their isoelectric pH. Okay. So the isoelectric pH is determined in the midway between the extreme pK value. Okay, so suppose eiti mu କହିବି, say for example serine. Okay, serine ro gote pK value hochi 2.1. So its alpha COH group can liberate one hydrogen ion at pH of 2.2. Its alpha NH2 group can liberate one hydrogen ion at the pH of about 9.2, and its R group, that means one hydroxyl group is there in serine, which can liberate hydrogen ion at about pH 13. So what can be the isoelectric point of this serine? So it is in between 2.2 and 13. So if we you just sum up these 2.2 and 13 and divide that by 2, you will get its isoelectric pH. So that is the peculiarity about this amino acid, that when they comes in their isoelectric point, so the charges will be same and they tend to coagulate or settle down, or you can say precipitated. Okay, so similarly these are the so you can just take screenshot of these two. So these are from Harper's Biochemistry. Okay, so now come to the secondary structure of protein. Okay, so the secondary what is the primary structure? Let us first know. So primary structure is nothing but the amino acid sequence in the peptide is known as its primary structure, whereas the secondary structure is that arises due to the rotation between this phi and psi bond. Okay, so phi psi bond tomar jete amount of co type of amino acid, what type of amino acid is present, and what is the bond angle, what is the rotation free space for this phi and psi bond, that actually determines the secondary structure. So in nature, there are actually two stable secondary structures. Stable secondary structure means in nature you will find those type of secondary structure in abundant as well as in stable structure. Stable माने सेटा सहजे dissociate हुएनी. So those two structures are your alpha helix and beta pleated sheet. Besides that, you will also find certain structures such as loops. Okay, turns, you will find those secondary structures are also there. Now come to this alpha helix structure, like that of your single DNA structure. The alpha helix structure is somewhat helical in shape. Okay, so here what you can observe, here the pitch is about 0.54 nm. So what do you mean by pitch? Pitch mane kon buchcho? What do you mean by pitch? Anyone? Any of you? I guess that any of you, can you just let me know if you have time? Just let me know what do you mean by pitch. So pitch is this one is known as pitch. Pitch means one rotation, where the structure completes one rotation, that axis is known as pitch. Okay, so in the alpha helical structure, what you will find, it has 0.54 nm pitch and it contains 3.6 amino acid residue. Now here you can ask me how the amino acid is in the fractionate condition, 0.6 residue. No, the amino acids are not in the fractionate condition, but on an average in an alpha helix, the nature, when they averaged the amount, they found that 3.6 number of amino acid residues are found in one rotation. And what they observed, that this first nitrogen group of the first amino acid is rotated, hydrogen bonded to the fourth carbonyl group of the carbonyl group of the fourth amino acid. Okay, so this is the alpha helical structure. Okay, so another type of structure is known as beta pleated sheet structure. So this is somewhat extended structure. So this is a compact structure. So helical compacted structure. Compact structure means because the hydrogen bonds are formed here, this structure is somewhat shorter than the beta pleated sheet structure. So this is extended structure. So there can be a parallel beta pleated sheet, that can be an anti-parallel beta pleated sheet. So in anti-parallel beta pleated sheet, what you will find, suppose this is one peptide chain, this is another peptide chain, this is another peptide chain. Okay, so what you will find, the directionality of this or the orientation of this peptide chain is opposite to this peptide chain, and the directionality or orientation of this peptide chain is opposite to this peptide chain. Okay, that means suppose epote roila tomra NH2 group, epote roila COH group, A chain tare kon thibo, epote NH2 group thibo, epote COH group thibo. Simti A chain tare epote NH2 group, epote COH group thibo. And the hydrogen bond is formed between the adjacent peptide chain of carbonyl. एठी जो carbonyl oxygen सहित एठी amide रो nitrogen सहित hydrogen bond formation होची. But here in alpha helix, what happens, in the single peptide chain, the hydrogen found between the amide group and the carbonyl carbon. Okay, that is the difference. So what will happen, it becomes a compact structure, whereas here the hydrogen bond forms between the two side chains, two types of polypeptide chain, it becomes the extended structure. So this is the structure of a anti-parallel beta pleated sheet, and this is the structure of a parallel beta pleated sheet, where here what you will find, the orientation is in a similar direction. माने एपटे amino group थिबो, ए peptide chain रो एपटे amino group थिबो, एपटे भी amino group थिबो. एठी सेमती एपटे carboxyl group, आ एपटे carboxyl group थिबो. Okay, so that is the difference between alpha helix and beta pleated sheet. Now come to the tertiary and quaternary structure. So in tertiary and quaternary structure, what you will find, in the tertiary structure, you will find there are certain super secondary structure known as motif. And in the quaternary structure, you will find there is domain. So a motif is a sequence of amino acids, okay, which can be joined with another sequence or another polypeptide. माने तमर टर्शियरी स्ट्रक्चर रे कोन हबो ना, तमर मने करो अल्फा हेलिक्स गोटे बीटा प्लेटेड शीट सहित जॉइन हेची, दैट इज योर tertiary structure. In a simpler way, I am explaining where the secondary structures are again connected with each other. That is your tertiary structure. Whereas in quaternary structure, there are certain domains which have certain functionality. Functionality means तमर टर्सियरी स्ट्रक्चर जेमती अल्फा स्ट्रक्चर बीटा स्ट्रक्चर कनेक्टेड हेची किंबा अल्फा अल्फा कनेक्शन हेची किंबा बीटा बीटा कनेक्शन हेची सेही टाइप रो थिबो बट each of those unit when it can function a particular function. Suppose this is the structure of a lysozyme, an enzyme. Okay, so it contains certain domains. So it contains two domains, okay, which have two types of functionality. One can accommodate this pyruvate, another can accommodate this NADH. Okay, so we can say that it has two domain. Okay, so that is the quaternary structure or folded structure in a protein. Okay, so as the time is short, so I should have gone to this enzyme part. Okay, so I couldn't. So if they will provide me extra class, so I will take this. Okay, this enzyme structure and this kinetics of enzyme. Okay, so again I request you, those who have not put their roll numbers in the chat box, they can put their roll numbers in the chat box. So any of you who has not put your their roll number in the chat box? So everyone has put. Okay. Okay, no problem. Okay, thank you. Thank you very much.
Thank you, ma'am.
Thank you, ma'am.
So if you have doubt, we can discuss in the next class also. Okay, thank you.